Hello students, welcome to section 4. In this section we are going to learn a new method that is called factorization method to solve quadratic equations. Now, before we start factorizing factorization method, we'll first see how we have solved quadratic equations previously. So we have an equation, let's say x square minus 6x plus 9 is equals to 0. So if we start substituting values, x is equals to 1, x is equals to 1 is not a root of this equation. Then if we substitute x is equals to 2, that is also not a root of this equation. And then when we reach to x is equals to 3, then that is a root of this equation. So the way we've been solving quadratic equations is by substituting values and checking them one after the other. But in this case, we are lucky enough that x is equals to 3 was a root of the equation. What if there is an equation, a quadratic equation we have that does not have a root close to the numbers 1, 2, 3, 4? Let's say I have an equation here, x square minus 95x plus 450 is equals to 0. Let's say I have this equation. So if we start substituting values from x is equals to 1, we will eventually reach to a value that is x is equals to 90. X is equals to 90 is a root of this equation. But then the question comes that it will take so much time to solve or substitute values for x one by one that it might not be efficient for us to solve this using substitution method. That is why there is a different method, factorization method, that exists so that we solve these type of equations in a very short period of time. So we are going to look after the theory of quadratic equations solved by factorization method. So we always start with the standard form of equation. Let's say I have ax square plus bx plus c is equals to 0. Now factorization means that I need factors. So as we have learned in our earlier classes that any number can have factors. We'll see that once again. So I need factors over here. So I need two factors such that we'll draw those factors first. I have b1 here, I have b2 here. So these factors should be such that when I multiply them, that means I need a product of b1 and b2. When I multiply them, I get the value a into c. So here I have my product, and when I add them, I get the value of the coefficient b. So this value here becomes the sum of these two factors. So from this we can conclude that we need two conditions to solve a quadratic equation by factorization method. So condition number 1 is that b1 b2 must be equal to ac. The product of b1 b2 must be equal to the product of a into c. And the condition number 2 is that the addition of both the factors must be equal to the coefficient of b. So once we have learned this, we'll move to an example from our textbook. We'll solve a standard equation on the left hand side and we'll solve our equation on the right hand side. My standard equation is ax square plus bx plus c. I'll make sure I draw the diagram, b1 here, b2 here. This is my product. This is a times c. And this is b. Now here I have a question which is 2x square plus 27x plus 13 is equals to 0. So before we start solving this question, we make sure that we define our coefficients first. So our a value here is 2, my b value is 27, and my c value is 13. Now The product of A into C is 2 into 13, which is equals to 26, and B is equals to 27. Now once I get this, I have to split them in two factors such that their product comes as 26 and the sum of those two factors comes as 27. So before we start, let's try to see if, check out few numbers. Let's say 27 can be split into 1 plus 26. So this is correct. So if I multiply 1 into 26, I get the value 26. So 1 comma 26 can be the possible factors. Then we'll check another number. Let's say 27 can be divided into 2 plus 25. 2 into 25 is equals to 50, but this is not equal to A times C. So 1 or rather 2 and 25 cannot be the factors because I cannot get the product of B1 times B2 equals to A times C. Remember, we need both the conditions to be true in order to solve a quadratic equation using factorization method. So in this page, we're going to make a table and we'll start solving. So here we have 2x square plus 27x plus 13 is equals to 0. Now remember, at all times we have to check whether b1 times b2 is equals to a into c and b1 plus b2 is equals to and b1 plus b2 is equals to b. Now we'll start off with using different sets of numbers. We'll try at least 3 so that we are able to understand how to get these sets. So first off, we'll start with 1 comma 26. So here b1 is equals to 1 and b2 is equals to, rather just let me make a correction. We have b1 is equals to 1, b2 is equals to 26. Now once I get this, all I have to do is multiply b1 into b2, which is equals to 1 into 26, which is equals to 26. And this value, I can say that b1, b2 is equals to a into c. As we can see from our equation, the value of a into c is 26. Now once I have established this, b1 plus b2 is equals to 26. So this implies b1, b2 is equals to b. Now as both the conditions have satisfied, that means this column has to be ticked. That means 1 comma 26 can be the factors. We'll see two new sets of numbers so that you all can understand how to split numbers. Let's say b1 is 4. So if b1 is 4, b2 has to be 23. So I'll multiply b1 into b2, which is 4 times 23, which comes out as 92. This implies b1, b2 is not equal to AC. And here again I have b1 plus b2, which is equals to 27. Oh, here I had plus. This implies b1 plus b2 is equals to b. This value here is 27 and this is b1 plus b2. If you have written this down in your copies, make sure you make the correction. This is b1 plus b2. Now this implies as both the conditions are not satisfied, that means 2 comma 25 are, or rather they cannot be the factors. factors. That means this is not possible. Now we'll see another set of solution. Let's say b1 is equals to minus 3. That implies b2 is equals to plus 30. So when I multiply b1 times b2, this is equals to minus 3 into 30, which is equals to minus 90. And this implies that b1, b2 is again not equal to AC. Now, the one thing that you need to understand that when I multiplied b1, b2 in this third case, I have a negative sign over here. It is very important to see that my AC has no negative sign. That means this value of AC, is positive 26. The sign also matters everywhere. So the product of b1, b2 in this particular case has to be positive, it cannot be negative. So any of the factors that I choose for values b1 and b2 cannot be negative. So once this condition is not satisfied, that means one of the conditions is not satisfied. That means those two factors that we chose cannot be the factors for this particular quadratic equation. So again, we have a cross here. So now clearly we have only two factors, which is 1 and 26. Now the question comes that what to do with these factors. So we are going to see how to solve this quadratic equation. So remember, we had our equation as 2x square plus 27x plus 13 is equals to 0. And my b was split into two values. One was 1 and the other was 26. Now remember, I am only splitting this coefficient. I am not splitting the x. So if I want to write 27x, that means I'll have to write it in this way. 2x square plus 1 plus 26 x plus 13 is equals to 0. I cannot remove the x as that is not possible mathematically. So once I do this, all I have to do is split the terms in such a way that I can get common factors. Now, how to choose which one or which number goes where? So I have here 2x square plus x plus 26x plus 13 is equals to 0. Now, as I can see, here I have 2 and from 26 I can get a common factor 2. So what I'll do is I'll take 2x square and 26x together. So here what we do, we get 2x square plus 26x and we take x to the other side, or rather on the next term, plus 13 is equals to 0. Now we have to replicate this particular equation on our next page. So we have 2x square plus 26x plus x plus 13 is equals to 0. Now all we have to do is focus on two things: how to get factors here, and once I get factors from here, that should be equal to this particular term. So we're going to see how to do it. Now what I can do here is I can see that 2 is common. So if I take out 2 as common value, I take 2 out common. So what is left in the bracket is x square plus 26. If I take 2 out of 26, it is left with 13 and there is x remaining, plus x plus 13 is as it is. Now as we can observe, I have x square plus 13x on the left hand side here. This value is equals to 0, and I have x plus 13 here. So what I'm trying to do is I'm trying to get two factors that can give me the quadratic equation. So now how to get x plus 13? As I can observe in my equation here, if I get x out, I'll get x plus 13 inside the bracket. So all I have to do is I have to take out my x value so that I'm left with x plus 13. So here I have 2 already outside the bracket. There is x common inside the bracket, so I'll take x common out. This becomes x. I'm left with x plus 13. This is plus x plus 13 is equals to 0. Now, what can I do is that 2x, I can write this x plus 13 as it is, and I can write here 1 into x plus 13. This does not change my equation whatsoever. So now, if I see this complete bracket, I have x plus 13 common inside for both the terms. So now what can I do is I can take out x plus 13 common outside the bracket, and I am left with 2x plus 1 inside the bracket. So that means my two factors become x plus 13 into 2x plus 1, and this complete equation or this complete product should be equal to 0. Now, in order to get the roots, we need to understand a very simple concept. So before moving on to solve the roots, we'll understand that concept. So let's pick a number. Let's say I have a value 4. If I multiply this by 0, the value becomes 0. Let's pick another number. If I have, let's say, 73, if I multiply this number by 0, that again becomes 0. Now, let's say I have to multiply 0 by any number. You can choose any random number, let's say 192. This again value becomes 0. Now, I know all of you know already, or know this already, but what is important here is that whenever we multiply any number by 0, the product is always 0. That means in order to get 0 in RHS, at least one of my numbers has to be 0. I can have both the numbers as 0 because even 0 into 0 is equals to 0. At least one of my numbers has to be 0. Now, once we have learned this, we'll come back to our equation and we'll see our equation over here. We have x plus 13 into 2x plus 1 is equals to 0. So we have x plus 13 into 2x plus 1 is equals to 0. That means if I have my RHS as 0, either this has to be equal to 0, or this value, this particular term has to be equal to 0. So how I solve this, I'll write x plus 13 is equals to 0, or 2x plus 1 is equals to 0. Now, if x plus 13 is equals to 0, that means x is equals to minus 30, or 2x is equals to 1 goes to the right hand side, this becomes minus 1. This is minus 1. Now, if I keep solving this as linear equation in one variable, I have already received my one root, which is x is equals to minus 13, and my other root becomes x is equals to minus 1 divided by 2. So my final values are x is equals to minus 13 comma minus 1 by 2. I can have both the answers as my solution, and this is how we solve a quadratic equation by factorization method. I hope this was very understandable for all of you. If any of you have any doubts, please do message me. I know this was a hard method to understand. All we need to focus on is the two values, or the two conditions that we did. B1 B2 is equals to A times C. That means the product of the two factors has to be equal to A into C, and B1 plus B2 has to be equal to B. As long as we satisfy these two conditions, factorization method is very easy. This session will end now. We'll continue in the next section with some problems to start, and then we'll move on to our practice set after that. Thank you.